All right, we'll show you a real quick rundown, quick review of using the formula, using the calculator to solve these things. So here's the situation. 96% of batteries produced by this company are good batteries. So we're going to take, a package of 6 batteries, find the probability. Exactly 5 last their full life, at least 4 last their full life, and no more than 3. So for us, let's make sure it's binomial very quickly. So run through 1, there's 2 outcomes. It's either good battery or bad, right? So it's good, or we'll just call it bad battery. Each battery is independent. Right? 3, we have a set number of trials. We got 6 batteries in our package. And then finally, the probability that we get a good battery is 0.96. So we are in a binomial setting. First thing that I'm going to do then is to come up with a quick table. 1, 2, 3, 4. Excuse me. Hold on. We got to start. We could have 0 good batteries. 1, 2, 3, 4, 5, or 6 good batteries. And then we're going to let the formula do the work for us. We're not going to go through and do all the individual outcomes like we have been doing. So in other words, this would be 6, choose 0. So if we want 0 good batteries, which would mean we have 6 bad batteries. Keeping in mind that we don't type it like that in our calculator, we would use 6, choose 0 right there. But we could type those into the calculator, and that number is 0.000000004. I'm going to call it 0. Not very likely that we get that. Here, it's going to be 6. We're going to choose 1. So we've got only 1 good battery, which means that we have 5 bad batteries. So again, this is going to be such a small number that it's not really worth putting all the zeros in there. The first digit doesn't show up until the 7th one. Now, we did 2, so 6 choose 2. So this time we've got 2 96s, which leaves us with 4 percentage. And this is the first one. I might go ahead. 1, 2, 3, 4. Okay. So for 3, this can be 6. We're going to choose 3. So this time we've got 3 good ones, 3 bad ones at 4%. That's going to be 0.0011, so on and so forth. So for the fourth one, 6 choose 4, 4 good ones, which means that we have 2 bad ones. And as you keep working your way through this, this one's 0.02, this one's 0.196, and then finally, with so many good batteries out there, more than likely it's going to be that we get a lot of good batteries, right? 96% of the batteries are good. So let's answer the questions. Exactly 5. What's the probability that x equals 5? Let's go back to the chart. X equals 5. Right there it is, 0.196. Probability at least 4. So in other words, x is greater than or equal to 4. Go back to your table. Greater than or equal to 4 would be 4, 5, or 6. So that would be 0.02 plus 0.196 plus 0.783, which is, just a moment, 0.999. Very likely that we have at least 4 good batteries. And then finally that we get no more than 3, so less than or equal to 3. And less than or equal to 3 is going to be everything from, so 3, 2, 1, or 0. You could also look at it as it's everything that we didn't just look at. So 0, 0, 0, 4 plus. I'm just going to go ahead and call it 0.001. Not very likely that we get that again. So, using the calculator, we started to show you this yesterday or today in class, depending upon when you were there. Um, Binomial PDF, and this is just my rule. I don't think this is at all what they, but helps if I can spell. P for a particular value, C for a continuous set of values. So in other words, binomial PDF, first you have to be, it has to be a binomial setting, but that's when you're finding the probability x equals something. Binomial CDF is when s is less than or equal to. Geometric PDF will be when x equals a certain value, and CDF less than or equal to a certain value. Now, one thing to notice, it's less than or equal to. So for example, let's say that we're trying to find the probability that x is less than 3. Well, we have to recognize that this is really the same thing as that x is less than or equal to 2, right? Even down here, right, it's still less than or equal to. So if you're doing some geometric setting, we want less than 4. Well, if you think about, right, if you have a chart with all this information, right, 0, 1, 2, 3, 4, there's stuff written in here. Well, less than 3, right, would be cut off here, and so that'd be 2 or below. Less than 4 would be everything probability that x is less than or equal to 3. So there's one of the tricks you got to be aware of in the calculator. The other is that they only do, uh, your calculators will only do down. So if we have greater than or equal to, what we're going to have to do is use the complement rule. So let's say that we want to find the probability that x is greater than 3. Well, sometimes I'll look at a table to figure out what the opposites are. So if we have the setting 2, 3, 4, 5, and without putting any numbers in here, we filled out our table. Well, the opposite of greater than 3, so greater than 3 would be everything this way. Well, the opposite of that would be x is less than or equal to 3. So we can use our calculator now because the calculator does less than or equal to. We just have to subtract that from 1 using the complement rule. So let's say in this situation, 9 out of 10 households, so 90%, in other words, it's kind of a weird way of saying it, but the probability is they have a DVD player is 90%, which means the probability they don't have a DVD player is 10%. Among 8 randomly selected households, that 5 of those will have a DVD. So in other words, probability x equals 5. So this is a binomial setting, so we're going to use binomial PDF because it's a particular value. And so when we get into our settings, whether you have the new operating system or not, the first thing you want to do is the number of trials. So we're doing 8 homes. The probability of success is 0.9, and then we're looking for 5. So out of the 8 homes, 90% have it. We're looking for that we get exactly 5.033. Don't have to set up the whole table this time. What's the probability? Exactly 7. Right? So again, this is a binomial PDF because it's a particular value. So this time we're going 8 homes again at 90%, and then we want 7, and that would be 0.383. What's the probability? 6 or more. So here's where we first run into this situation. Um, if you'll allow me to kind of go to the top to kind of make my point here. Let's say that we were looking at the table. We think about just part of the table, 4, 5, 6, 7. All right, we cut off part of our table. So greater than or equal to 6. Remember, our calculator doesn't do this, so we need 1 minus. And it is going to be continuous this time, right? We have less than or equal to. So CDF. But we need the opposite of greater than or equal to 6. Well, greater than or equal to 6 would be everything from 6 up. So the opposite of that for us will be 1 minus the probability that x is less than or equal to 5. So 1 minus, and then you can type it just like this in the calculator. CDF, we've got 8 trials, the probability of success of 0.9, and then we want 5. So 1 minus 8 trials. If you'll let me put it right here, 0.967. And then finally, what's the probability um, that we have 5 or less? So x is less than or equal to 5. So here we go. This one will go, we can go straight to binomial CDF because it's going down out of the 8 trials with a 90% success rate that we have 5 or less. We actually just saw that. Um, excuse me just a second. I realize up here number 3 I rounded the wrong way. This isn't. This is actually 0.962 in number 3. Apologies. Um, so here, if I can get back to it, binomial CDF because it's continuous, 0.038. I realize that because 3 and 4 are closely related, right? They both use that binomial CDF 8, comma 0.9, 0.5, and somehow those weren't adding up. So very quickly too, I can use the same type of problem on my local paper route. Was probably the first home with a DVD is the 4th house. So this until success, right? Until success. Um, this is now a geometric setting. So what's the probability that the first home is the 4th? So the probability that x equals 4. So this is a particular. So this would be a geometric particular value. And so when you go into that distribution, um, this time we need the number that we're after, or the probabilities first. So again, the probability of success is 0.9, but this time um, we don't have a set number of trials. We just know that we want the 4th house. So for us uh, here, that's 0.0009. Right? On my paper route, what's the probability I will visit at least 3 houses before finding? So probability that x is greater than or equal to 3 houses. Again, we're going to have to play a trick here. What's the opposite? If we think about this for just a minute, what's the opposite? 0, 1, 2, 3, 4. The problem with this here, again, geometric, there's no end in sight. It could keep going on and on forever. It could be the 4th house, 5th house, 6th house, 7th house, 8th house. Well, at least 3. So what's the opposite of at least 3? So at least 3 would be everything this way. So the opposite would be 1 minus the probability that x is less than or equal to 2. So here we can go geometric CDF. Right, so once you're in that distribution, again, the probability is 0.9. And then the x value for us, we're after 2. So we're going to do 1 minus that. And that is 0.01. There's a 1% chance it'll take 3 houses or more. I visit no more than 2 houses. So here, that's the probability that x is less than or equal to 2. Since we're at less than or equal to, calculator, we don't need to play a trick. That's just going to be geometric. CDF, because it's continuous, 0.9, 2, right? And that value, once you plug it in, is 0.99. So it's an alternate. Instead of having to go through the formula, instead of having to do a bunch of stuff by hand, we can actually use the calculator, and it's very, very